Hello, dear learners. So, today we are going to start a new topic of electrostatic, and that is electric field. Actually, this is the part 4. Already, we are done with the three parts of electric field, and again, we have a numerical from electric field. So, without wasting time, let me go to the numerical. So, the numerical is that we have two charges plus 2 microcoulomb and plus 2 microcoulomb, right? So both the charges already shown in the figure, right? So we have a charge plus 2 microcoulomb here and another charge plus 2 microcoulomb here, and they are separated by a distance of 10 into 10 raised to the power minus 2 meter. So from the center, I took the distance that is 5 into 10 to power minus 2 meter, right? And we have to find out the net electric field at this point, due to these two charges. And this point is at a distance of 30 into 10 to power minus 2 meter, right, from this O. So this is the first combination when we are using the two charges as the positive charges, and then we have to find out the net electric field at certain distance at from point O. In the second combination, I will choose one charge as a positive charge and other charge as a negative charge, and then we will calculate the electric field intensity at this point. And in the third combination, I will take both the charges as the negative charges, and then what is the resultant electric field and its direction also, right? In all the three cases, we will find out the magnitude of electric field and the direction of the electric. So let me start with the first case. So this is my case first. The first case, when both the charges, they are positive charges, right? And this is the center, this is the point O. From point O, and this charge is at a distance of 5 into 10 to the power minus 2 meter. Likewise, from the center O, this charge is at the same distance, 5 into 10 to the power. This is again same, 5 into 10 to the power minus 2 meter. So I think question is clear to everyone. Now, this electric field is due to this charge, and this electric field is due to this charge. I have shown both the electric field as E because I have the like charges. Both the charges are Q. Okay. So how to find out the net electric field? So let me draw my x-axis. This is my x-axis, and let me assume this electric field makes an angle theta with the x-axis. Likewise, this electric field makes an angle theta with the x-axis, right? So now this electric field is at an angle of theta with x-axis. So I will resolve this electric field into two components, right? So the one component, right, that will be the vertical component, and this component will be E sine theta, and other component that will be the horizontal component. This component, right, this will be the horizontal component along x-axis, that this will be E cos theta. E cos theta. So I resolved this electric field, which is at angle theta, into two components: E sine theta as a vertical component, E cos theta as a horizontal component. Likewise, I will resolve this electric field into two components, right? One as E sine theta, and other as in the same direction, E cos theta. So finally, this will become 2 E cos theta. Okay. So now I can cancel the vertical components. So you see E sine theta and E sine theta, they can be cancelled because these are two vectors which are vertically opposite in directions, right? Both are vertical. One is vertical up, other is vertical down. So in this case, I can cancel these two vectors. But here I have two vectors, E cos theta and E cos theta. E cos theta due to the upper electric field, and then again E cos theta due to the lower electric field. So finally, we have two E cos theta. So in this case, the net electric field, at this point, net electric field at the point P. Let me take this as point P. So this is my point where I am observing the electric field. So that will be equal to 2 times E cos theta. And now we know that E can be written as K times Q divided by R square and cos theta. So this is the formula to calculate the electric field. And if we substitute the values, then we can find out the electric field. So let me just put the values. So 2 and the K is 9 into 10 raised to the power 9, and the Q is 2 microcoulomb. So 2 multiply 10 to power minus 6 coulomb, right? And R square. Now this distance, if you calculate this distance, it will be 30.41, 30.41 multiply 10 raised to the power minus 2 meter, right? But we need to scale it. So 30.41 multiply 10 to power minus 2 as whole square. And then finally cos theta, right? So you take this angle, you can take this angle also theta. So in this triangle PO, and you can use as Q. So in this triangle POQ, you can find out cos theta, which is base, right? This is the base and upon hypotenuse. So base is 30 multiply 10 to power minus 2, and hypotenuse is 30.41 multiply 10 raised to the power minus 2. So you see this 10 to power minus 2, this 10 to power minus 2, and this 30 will be cancelled by this 30. So approximately this value becomes nearly equal to the 1. So this value becomes nearly equal to 1. Now, if we calculate this value, so I'm writing the final result, you can do the calculation. So the final result that will be equal to 3.84 into 10 raised to the power 5 Newton per coulomb, right? So this will be our final answer of this numerical. So here I took the two charges, like charges having the same magnitude, plus 2 microcoulomb and plus 2 microcoulomb. And from the central point, the distance of the upper charge was 5 multiplied 10 to the power minus 2 meter. Likewise, the distance of the lower charge was also 5 into 10 to the power minus 2 meter. And the point P was at a distance 30 into 10 to the power minus 2 meter from the central point. So we were interested in the electric field at point P. So the electric field at point P, that comes out to be equal to this. Now, the direction is towards right, towards. So this is the direction towards right, or we can say this is towards positive x-axis. So we can describe our answer in two ways. We can say it is along a right direction, or we can say it is along positive x-axis. Okay. Let me take the other combination. In the second combination, I will choose one charge as a positive charge and other charge as a negative charge. So let us take that. Again, the same. So now I take the second numerical. In the second numerical, right? So this is my question number 2. And in question number 2, now I will take the two charges. One as the plus 2 microcoulomb, and this is my point charge, and other is minus 2 microcoulomb, minus 2 microcoulomb. And the separation between them is 10 centimeter. And if I take the central point, if I divide into two parts and I convert this 10 centimeter into the meter, then upper part will become 5 into 10 to the power minus 2 meter. Likewise, the lower portion will also become 5 into 10 to the power minus 2 meter. So now I have two charges. Let me write this as Q. So Q is this, and again, this is also Q, right? And from this central point, we take a point P. This is my some point P, and the distance is 30 into 10 to the power minus 2 meter. So at this point, now find out the net electric field, magnitude of net electric field and its direction. So let us start. So due to this upper charge, there will be an electric field along this direction. And now, due to this negative charge, there will be electric field along this direction. Because if we put a test charge at this point, the positive test charge at this point, then the positive charge will feel a repulsion due to this positive charge. So the force and the field, they will be along this direction due to this charge. But this positive charge will feel attractive force because of this negative charge. So now the direction of force and the direction of electric field, they will be along this direction, right? So let me draw my x-axis. So suppose this is my x-axis. So with this x-axis now, this angle is theta, right? And this angle is also theta, right? Why both the angles are same? Because the magnitude of both the charges, that is same, so they will produce the same electric field. So this electric field and this electric field, they are same. So it means the net electric field, that will be uh, not, if I resolve, I will not discuss about the net electric field at this point. So first I will resolve the two electric field. I will resolve the two electric fields. So now, if I resolve this electric field into two parts, so this component will become E sine theta, and the second component that will become E cos theta, right? So I resolve this electric field into two components. One component E sine theta vertically downward, other component E cos theta along the x-axis. Likewise, if I resolve this electric field into two components, so again, E sine theta will be along this direction, E sine theta will be along this direction, right? And E cos theta will be along this direction. So in this direction, we will have E cos theta. So if you see this E cos theta, they are vertically opposite. They are opposite, so they will be cancelled. And finally, the addition of these two, they will be added, right? And finally, we will have 2E sine theta, 2E sine theta, right? So this will be the final electric field in the downward direction, and this is the magnitude. So we can calculate this. So E can be written as KQ by R square, and this is sine theta, right? So you can calculate, now this is 2 multiply 9 into 10 raised to the power 9, and Q is 2 microcoulomb. So this is 2 into 10 raised to the power minus 6 divided by R. So R, this is the R. So if you calculate R, so that will come equal to 30.41 multiply 10 to power minus 2 meter. So this will be my R. So R will be equal to this. So now I have to do R square. So means 30.41 multiply 10 raised to the power minus 2, and then whole square, this whole square, and then multiply by sine theta. So I can calculate sine theta in this triangle. So this is my point P. So POQ, this is Q. So in triangle, you can choose the upper triangle or you can choose the lower triangle. So find out the sine theta. So sine theta is perpendicular upon hypotenuse. So perpendicular is 5 multiply 10 to power minus 2, and hypotenuse is 30.41 multiply 10 to power minus 2. So this 10 to power minus 2, 10 to power minus 2. So if you do all the calculations, so my answer is 6.3 multiply 10 to power 4 Newton per coulomb, right? So if two charges are given at 2 points, and the two charges, they are equal and opposite charges, means one is positive, other is negative. So how to find out the electric field at some point P, which is at a distance 30 into 10 to power minus 2 meter from the central point, right? Now, if we are given in third part, I will take, if we are given both the charges as negative. So how to do that if both the charges are negative? So the third question is, if both the charges are negative, means this is minus 2 microcoulomb and this is again minus 2 microcoulomb, and everything is same. All the distances are same, right? And this is my central point, and from the central point, right? So this distance is 5 into 10 to power minus 2 meter, upper half, and the lower half also 5 into 10 to power minus 2 meter, right? And from this point O, we have a point P. This is the point P, and the distance of this point P is 30 multiply 10 to power minus 2 meters. So we have to calculate the electric field at point P due to these two charges, right? So how to calculate? Now, if we place a test charge at point P, means we place a positive test charge at point P, so what will happen? The upper minus 2 microcoulomb, it will attract this charge, right? And the direction of attraction, that will be this. So it means the direction of force and the direction of electric field, they will be along this direction. Likewise, the lower minus 2 microcoulomb, that will attract this test charge, and the direction of electric field and the direction of the force, that will be along this direction, right? So if I resolve the upper electric field and the lower electric field into components, so let me take this angle as theta, this angle also as theta. So now I can resolve this. So again, let me make the diagram again. So let me make the diagram again. So we have two charges, minus 2 microcoulomb and minus 2 microcoulomb, and both the charges are negative, right? So this is my central point. From central point, I choose a point P where I want to find out the electric field, the net electric field. So this will attract the test charge at point P, and the direction of electric field and the direction of force, they will be along this direction. So if we place a test charge at point P, that will be attracted by the upper minus 2 microcoulomb. Likewise, the lower minus 2 microcoulomb, that will also attract the electric field, and the direction of the force and direction of field, they will be along this direction. So if I choose the angle, if I choose this angle as theta, so this will again be theta because the magnitude of the charges, they are same. So first of all, I will resolve this into two components, right? So this will become E sine theta, right? And E cos theta will be along this direction. This will be E cos theta, right? E cos theta, E cos theta. Okay, so I resolve this E into two components, E sine theta and E cos theta. Likewise, I will resolve this E into two components, right? So this will be E sine theta, and again the E cos theta will be again in this direction. So I can write this as twice E cos theta. So these two will be cancelled again, and the net electric field at point P, the net electric field at point P, that will be along 2E cos theta, right? And it will be along minus x-axis, means in the left direction. So you can calculate this as 2 times E can be written as K times Q upon R square and cos theta. So you apply the same method and you can find out the resultant electric field, right? So let me solve this for you. So 2 into K is 9 into 10 raised to the power 9, and Q is 2 microcoulomb, means 2 into 10 to the power minus 6. And again, R square. So if you calculate R, means this hypotenuse, so this R, that will be 30.41 into 10 to the power minus 2, and then whole square, Okay, so now you need to calculate cos theta. How you will calculate the cos theta? Just take this triangle. In this triangle, you find the cos theta. Cos theta is equal to base upon hypotenuse, right? So base is 30 into 10 to the power minus 2, and hypotenuse is 30.41 into 10 to the power minus 2. So again, this part will be nearly equal to 1. This will be nearly equal to 1. So, and if you do all the calculation, so the final answer, that will be equal to 8, 4 into 10 to power 5 Newton per coulomb, right? So it is similar to the first case, but in the first case, the direction of the field due to the two positive charge that was towards right. Now we are taking the two negative charges, so direction that will be just opposite to that, right? So this will be along negative x-axis, minus x-axis. Okay, that's all. Thank you.